Grab that. Thank you. Okay. So question 3 on homework 4, this is the trickiest one on the whole homework. And the tricky part about this is that it's not quite written in one of the 2 forms that we had given you in your notes. So you have to do a little bit of sneakery to identify the vertical or horizontal asymptote. It's really the vertical asymptote that's the issue. So if you wanted to still keep it in the first form, what you would do is we'll factor out a 3 from the denominator. And then I'm going to push this 3 into the numerator by turning this into 2/3 rather than 2. And that'll get the 3 out of the denominator and into the numerator. And at that point, I can see the h is -1 and the k is -2. Alternatively, if you tried to get into form denominator with the -2 and then added the fractions, that would work also. You'd end up with the same result, or the same values for your vertical or horizontal asymptote. But that's the trick for that one. It was a mean trick, but who said I wasn't ever mean? I'm not trying to be mean, but like, you know, it's okay to trick you in the homework every once in a while. Better here than on the test, you know what I mean? Yeah, that got your attention. So we'll do that. And now when I'm plugging these values in, I'm going to just go back to the original before I altered it to identify the h and k, just because it's easier to plug it in to do in my head if everything is a whole number and there's no fraction or anything. That's cool though still? Yes, sir.
What is the domain and range? What is the letters?
So that just stands for all real numbers. So I did ARN. And then I have not equal to the value for the vertical asymptote for the domain and the value for the horizontal asymptote for the range. And again, I use x's for domains because the domain is about the x-axis and y's with the range because the range is about the y-axis. Yep. Is that cool? Still doing good, Kalila? Okay. I'm guessing that it was just figuring out that vertical asymptote that was the big issue. But we'll finish this out just for the sake of completion. All right. So plugging in -4, that gives me 2 over -9. And then -2, which is like 2.2 repeating, or -2.2 repeating. And then that's going to give, plugging that one in, that gives me 2 over -6. So that's like -2.3 repeating. And if I plug in -2, that's like 2 over -3. So that's going to be -2.6 repeating. If I plug 0 in, that's going to be 2/3, so that's -1.3 repeating. And then that's going to be 2 over 6, so that's going to be -1.6 repeating. And then that one's going to be 2/9, so that's going to be -1.7 repeating. So again, like if you're more comfortable doing that stuff on your calculator, like mental math with fractions maybe isn't your thing, like totally fine. Type all that junk into the calculator, not a big deal. I'm just a little bit faster probably without the calculator, especially when I have to like mouse over and it's just kind of inconvenient for me. But all that arithmetic, all I'm doing is plugging the value for x in to the problem and evaluating to find the y. Everybody's okay with that? So let's draw our graph then. I'm going to start by putting in my asymptotes. So there's my vertical asymptote at -1. And there's my horizontal -2. Then I have -4 and -2.2. And then -3 and -2.3. And then put that asymptote in +1, not -1. You know, sometimes you make a mistake. It is 8 o'clock in the morning or whatever. And then we have -2.6. So there's that. And then the other side, I have 0 and -1.3, 1 and -1.6, and then 2 and -1.7. And there we go. Coolsville. Again, the tricky part was figuring out that vertical asymptote piece, but once you did that, it was no big deal. And just to maybe make this even more broadly easy, really what you're doing when you're getting that vertical asymptote is all you're really doing is finding the value that gives you a 0 denominator. So if you just take your denominator and set it equal to 0 and solve, that'll give you your vertical asymptote also. Which in a case like this is maybe an even easier approach than what I did initially. So I said that in general, what we're doing to get our vertical asymptote is just taking the denominator, setting it equal to 0 and solving, which might be an easier thing to remember than like all these little formulas or whatever for that. But that'll work also, regardless of what form.
So you can do that for any problem too?
Yes. Yeah. Yes. Regardless of what it is, you can always do that. That'll always work for you. For any, well, I should say for any of these simple rational functions, that'll always work. For general, we have to be a little bit more careful than that, but we're not doing that in this class, so don't have to worry about it. Anyone else with questions from homeworks? They don't have to be just from homework 4. If you have other stuff from previous things that we've worked on that you circled back to after seeing some more examples yesterday or last time, and want to take another run at, that's cool too, but no pressure. Yeah, Walter?
Can you do 5 from this worksheet?
Homework 4?
Yeah.
Number 5. Sure. Just grab it. Okay. So this is like in that second form. So my vertical asymptote is going to be negative d over c. So d is -3 and c is 4. And the horizontal asymptote was a over c. So the in this case is 2. So the domain is everything except for the vertical asymptote. And the range is everything except for the. The vertical asymptote goes in the middle of my table. And then I'll just pick 3 values that are less than it and 3 values that are bigger than it. And then to fill in the rest of my table, I'm just plugging those x values into the original problem to get my y value. So when I plug 0 in, I get negative 5/3, which is negative 1.6 repeating.
So we can't put fractions, right? We have to turn them into decimals.
I turned them into decimals because if I'm graphing, it makes a lot more sense to where like 0.75 is than 3/4, right? It's easier to plot that. Since we're plotting these things, I'm going to leave them as decimals rather than using fractions because, you know, like, again, negative 5/3, where does that go when we're graphing? It's not entirely clear right away. Having the decimal makes life just a little bit simpler. Let's see, I plug the -1 in, that's going to be 3/7. I think that's like 0.42-ish. I'm trying to remember now. And that's plugging -2 in, that's going to be 1/11. I don't know what that is, but it's, or -1/11, but it's pretty close to 0.1. Close enough to where I'm okay with that. Again, if I can do it to 1 decimal place, I'm probably safe. In terms of plotting, right? I'm not going to draw something so accurate that I can get it within 2 decimal places. You know what I mean? You can only do so much by pencil and paper. When I plug in 1, I get 7/1, so that's just 7. And then I get, I plug 2 in, that gives me 9/5, which is like 1.8. And I plug the 3 in, that gives me 11/9, which is like 1.2 repeating. All right, so -2 and -0.1. -1 and, -1 and -0.42, and then 0 and -1.6. Uh, 1, 7. I don't know, 7's got to be like up there somewhere. 2 and 1.8, and then 3 and 1.2. So there's about that. Again, I tried to pick things that stayed on the x-axis or stayed on the xy axis. I guess when I made this one up, I didn't think. I probably did 2, 3, and 4 when I previewed the problem instead of using 1, and that's, if I did that, everything stayed on the graph pretty nicely, but whatever. No big deal. If you have something that's a little bit off the graph, you know, you just guesstimate it up there. I'm not going to be too picky about stuff like that. As long as you're able to interpret correctly what the graph should look like and you have the correct numbers in your table. If you have some stuff that's off the chart, so to speak, that's not the end of the world. No big deal. You know what I mean? I think that's a reasonable standard, right? Ooh, that sounded like it hurt. Sure. All right, so we've finished the content here for this chapter. That's nice, right? Considerably shorter than the previous chapter, which felt like pretty unwieldy by the end because there was so much stuff going on. This should feel quite a bit more manageable because there's so much less content to deal with, right? And in general, I think these problems are much less time-consuming than the worst problems from chapter 5, which could be very time-consuming. So if we go to the content library and you take a look, you'll notice that I've put up the chapter 9 review. And the level of difficulty will be similar. So in the review, I have 2 problems where I ask you to reduce. I have 3 multiplication or division problems. I have 3 addition and subtraction problems. I have 2 mixed problems where we have like addition, subtraction, and multiplication, division going on at the same time. I have 5, I think, solving problems here. And then I have some graphing problems here at the end. I think I have 2 of each kind of graphing. Yeah. So, review. Everybody okay with that? So that'll be the same kind of format as your test. You'll have the same types of questions, fewer quantity of them in each. Like there won't be any more questions in any section than you do on the test, and overall you'll have less questions on the test than you do on the review. Answer key for the review. So this has all the worked out solutions in it for I work in here also so that as you're working on this, all that stuff is kind of there for you within reason. So, the algebraic stuff, I have a lot of work written out for you. The graphing stuff may be a little bit less. And you will probably have to zoom in a little bit because I have got awful tiny handwriting when it comes to actually writing on a sheet of paper with a pencil or whatever. It works since we won't have another chance to meet before we do the test. Right? When is the test? Next Monday, right? So not the coming Monday, but the Monday after that. But we don't meet again in person before that. So that's why I'm giving you all this extra stuff that maybe you don't always get. Is that okay with you guys? I'm going to give you the rest of the period here.